The mass spectrum for 4-methyl-2-pentanone is shown below. Which fragment represents the peak at a mass to charge ratio, M over Z value, of 85? Okay, so we have the structure here of 4-methyl-2-pentanone, and typically the heaviest peaks, that's the highest mass to charge ratio, is typically your molecular ion, but we could confirm that with the structure of our 4-methyl-2-pentanone. So if you went through and you highlighted where you have all of your carbon atoms, you would see that you have 6 carbon atoms. If you were to fill in all of your hydrogens, we'll do this really quickly so that we have it. All right, so just filling in the valencies to make sure that carbon has 4 bonds in each case. All right, so if we did that, we would find out that we have 12 of those hydrogens. Right, so here is our molecular formula. And if you were to sum up the mass of this, you'd find out that that does weigh 100 atomic mass units. So this is our molecular ion. Okay, so that's our M+ peak. So this would actually be what that looks like in your mass spectrum, is this radical cation of the entire molecule, right? Because we know that when we take a molecule and we put it in the mass spec, we hit this with a high energy beam of electrons. So it knocks off 1 electron, meaning you end up with 1 unpaired electron and a positive charge, and that is what is known as M+, or your molecular ion. Radical and a cation, not really stable, so this breaks down further to give you charged fragments and a radical that's lost. And it's the charged fragments that are viewed in your mass spectrum. So these charged ions appear in the mass spectrum. Okay, and we've got a few that are highlighted here, but we're being specifically asked to identify what is the structure at this mass to charge ratio of 85. So when I see a number like this that's pretty close to the molecular ion, I think that subtraction to find out what has been lost is a good approach here. So if we look at what has been lost from this molecule. So what has been lost from, we'll go ahead and say the molecular ion, from M+. So we say, okay, well, we started with a mass of 100. If we're left with 85, we have lost a fragment that weighs 15. And so after you've done a few of these problems, you might start to recognize that a loss of 15 is typically the loss of a methyl radical, okay? And so we've got a few different methyl groups on our 4-methyl-2-pentanone, so it's helpful if we know something about how ketones fragment. So I'm gonna go ahead and redraw this structure. All right, so here's our ketone. So the major fragmentation patterns of ketones is to fragment alpha to that carbonyl group. So I'd expect to see fragmentation here. If we did that, we'd be losing all of that piece. All right, so you'd be losing that as a radical. Or if you do fragmentation on the other side, you're just gonna lose 1 carbon atom and 3 hydrogens. So fragmentation here is the loss of that methyl group. And so when you lose that, then you're gonna have the positive charge right there on the carbonyl carbon, which is what we see here in option B. And so the reason why we see that fragmentation pattern is because this cation that we're left with has resonance stabilization. So these lone pairs of electrons on the oxygen can come in to form a triple bond in this case. Right. And so in this way, the oxygen is able to share that positive charge, which makes this a relatively stable fragment. So that's what we're seeing there at 85. That's not the base peak, right? So we've solved the problem. The answer is B. So go ahead and stop watching if you don't want to see more details. If you're curious though, that base peak would be the result of the opposite fragmentation. So this pink line here would give you this as the cation, right? And if you add up the mass of this one does weigh 45. You've got 43. You've got 2 carbon atoms, 3 hydrogens out here at the end, so H3, no hydrogens on that carbonyl because it had 4 bonds to start with, and 1 oxygen, and that shows up at 43. So that ion ends up being our base peak, but in this case, we were not asked about the base peak, we were asked specifically about the peak at 85.